In the next presentation panel, you are going to hear from a number of people who are actively involved in either developing or currently using virtual reality, high-definition images in order to enhance the experience of people. And to lead this panel, I'm very happy to introduce Walter Greenleaf, who, with a background in bioengineering and medicine, has a significant career in new technologies that are applied to medicine, and was one of the very early pioneers in establishing the use of virtual reality for therapeutic purposes. He's a distinguished mediaX visiting scholar, and I'm very happy to welcome him. He will introduce the panel to you. These are things that are happening now.
Thank you, Martha. While the panel assembles, I'll mention how excited I am to be here. I first got involved in medical applications of virtual reality technology in 1985, so 30 years ago. So you can imagine how excited I am to see that it is happening now, that finally we're over a threshold and the technology is about to leap forward and be available at an affordable price, and probably more important, in a way that's comfortable to use. I'm very excited about our panel today. I'm going to jump right into it, and we only have a little bit amount of time, so people are going to be moving at a brisk pace. And with that in mind, I'm going to ask Marcelo to start. Let's sit down. We'll have a little bit of time for questions, but please introduce yourself, give your background. I think if I were to try and describe everybody's background, it would take me 20 minutes. I'll let you do the redacted version.
Okay.
Great.
My name is Marcelo. Good afternoon, everyone. I'd like to thank mediaX for the invitation. I'm the Chief Innovation Officer of Sábia Experience, which is a Brazilian company dedicated to education, immersive education platform. I invite you to visit our demos there. And basically, we have been working with developing a platform to train workers in industries where there are many accidents, and the training is very important to have the vision and immersive education in relation to behavior of the workers. I give an example as oil and gas platforms. They have to learn from accidents, from former accidents. And what we develop is a platform where workers get together and play as a team, trying to solve the problems of that, the root causes of the accident. And we gamify the content. Actually, we developed an altering tool that the companies develop their own content, because it's the trick part of this is the success of our platform is the content really must be authentic to the workers. So the companies create their own content, use their own language, using their own images and symbols, and we have a platform, a template they can gamify, and the workers get together as a group and interact with each other and learn from other accidents. And what is interesting, as a group, they share content and experience among each other as a peer-to-peer learning. So it is a different approach. It is an innovative approach in the world, because we take the advantage of the immersion and digital world, but keeping the social side, the social meeting, the social game as in the same level. So it is a mix of the presence and virtual at the same time. So you can take a look in the demo. I invite you to visit us over there. Okay, thank you. I appreciate your attention. Thank you.
Thank you, Marcelo. Do you have any slides to show us?
Yeah, I
okay.
just have some pictures.
Yeah.
Some pictures. Okay, let me give you some of the picture visualization. You see some of the workers there. You see, this is the platform, in the oil and gas platform of the Petrobras. The workers are handling augmented reality plate. You can see that in the demo. So they can analyze the 3D image and trying to discuss as a group how to solve the problem. Okay, this is a very interesting experience, how to train Chinese workers in a Brazilian company in Africa. They were developing, Chinese workers are building a railroad. So it works in different culture too, but the system handles text-to-speech in different languages. This is an application for the mining industries in Brazil. Workers get together and play as a team and learn from each other. And we built a truck for the construction industries. So the workers get during the construction, there is no space, special space for the experience, for the immersion. And so they go to the truck and play the games and learn from each other. It's fun. What is the real life result is the workers love to be part of a game and learning from each other, using augmented reality. Corporations love to be authentic and create their own content. It's very important. It took us 2 years just to develop the altering tool in order for the companies to create their own content. This is some of the impacts. Less than 1% of the workers get involved in accident. Again, in 15 minutes of the game can be equivalent of 1 hour class in terms of the retention of knowledge, 50% test improvement. And for the long term, even 1 year after the training, just one game in 15 minutes, they can recall what the storytelling of the accident, the training. So the future challenge is to become ubiquitous and applying in different sectors, creating an access system, finding a partner, many partners of contents, creating innovative business model and application, not just areas in industries, but also retail, service, education, and franchising. Thank you very much for the attention. Again, I invite you to visit our demos there. Right. Thank you very much.
Yeah. Thank you. That was fantastic. You mentioned several metrics of success for your program, safety, speed of learning, retention of learning. Which one do you think is propelling, what's the most compelling one of the mixture of things that have been successful for you? What's driving this?
What the companies are telling us is that today, because of the very competitive market, the time needed for the education training programs are really tight. So they ask us for the efficiency for the time used. So we use a knowledge pill. It's 10 minutes and 15 minutes. That's the maximum a day, every day. So this little pill, it's good for the companies. Yeah. They don't want us to spend an hour in a classroom with all the workers, right? In terms of productivity, so that's the main point.
Fantastic, okay. Especially with cross-cultural. That's very important.
Sure.
That's great.
Thank you.
Our next speaker, Kyusub Kwak, is going to give us a discussion of his technology, working with Samsung.
Yeah. Good afternoon. My name is Kyusub Kwak from Samsung. I'd like to start my talk with market. According to one of the market forecasting company, total cumulative device unit sold to 2018 equals about 57 million devices. So as the unit sales increase, total hardware revenue grows to about $1 billion at this year. And at 2018, hardware revenue from device sales is estimated about $2.3 billion. In the software side of the market, the software revenue will be increased to about $1 billion at this year and will reach it at 2018 about $2.8 billion. In this situation, our company Samsung launched the first Gear VR last year with the price of $199. As you know, the Gear VR consists of a simple optical part and mechanical part to support optics and smartphone joint. We use the smartphone as a display, so we adapted high resolution display to the phone. Actually, operation mechanism is based on the 3D stereoscopy. After inserting smartphone to the Galaxy Gear, GeoVR, and then software split the picture into two warped circled display, side-by-side view. And that work with the lens to create the best 3D viewing area. The first version, GeoVR, is compatible with the Galaxy Note 4, which has 5.7 inches, 2560 by 1440 pixels. Actually, I think this resolution is not enough, but tolerable until now. Actually, in the device point of view, wide angle is very important because that gives an immersive user experience. Actually, normal human viewing angle is about 100 degrees, so we try to widen the viewing angle to 96 degrees without display distortion. For user interaction, GeoVR has several physical keys such as touchpad, volume key, back button, and sensors such as gyrometer, magnetic accelerometer, and proximity sensor. Actually, GeoVR can be controlled by physical key directly and navigated by head motion. So I think we can see the content from GeoVR. If you go to the YouTube, you can see the battle for the Avengers Tower made by Samsung and Marvel collaboration. Actually, in this film, you can wear Tony Stark's Iron Man suit and you can take a battle. Actually, you can control something, yeah. But you can get a pretty decent looking with GeoVR. Actually, until now, most VR application is restricted to the gaming and entertainment. But I think in near future, VR area will be wide in variety domains. Now I'd like to share my questions. Actually, there are many technical hurdles until now. The first thing is the discomfort of user experience. This is based on the wearing discomfort, as you know, the big hardware, and visibility discomfort based on the divergence, accommodation, completion, and the unnatural user interface. Actually, most of current commercialized HMD devices are very big and heavy because they have an optical system, complex optical system. Requirement as short focal length, and no distortion, motion parallax, etc. So we should overcome this problem with the new technology like light field display. Another problem is the user interaction. Actually, after we wear the HMD device, we are blind. So if we use the joystick, we should take off the HMD to find control and finding or figure out the button. Finally, I think the last issue is the lack of content and service platform. Actually, for wide spreading and rapidly increasing the market, we should involving the public user to the ecosystem, but we have no appropriate creating device and appropriate service platform. So I think we can overcome these technology issues and business issues in near future. So actually, I came here just about 1.5 months ago. I'm come to find the solution for overcome this technology. So today's conference will make me more inspired to the new technology. And thank you for Master and mediaX collaboration colleagues. Thank you.
Thank you. I think what I'll do this time, instead of having us ask Q a question, I'll ask people in the audience a question. How many of you have used a Samsung Gear VR system?
Oh,
Wow. How
Thank
many
you.
own, how many own one? Wow. I'm going to buy several for Christmas for my
Yeah.
sons. Thank you, and thanks Samsung for introducing this pioneering product to help us get moving with this new wave of technology.
thank you.
Thank you. All right. Okay, next.
Okay. So I'll use the slides here. Okay. Okay. Hi, I am Takeshi Kurihara. I'm a visiting scholar at Stanford, and I work for the NHK. That's a Japanese TV station, public TV station in Japan. And I must explain that I'm not one of those tech experts. I'm a journalist. I cover stories about those classic stuff like policy and political stuff and diplomacy and those things like that. But I'm offered a chance to explain our efforts of broadcast technology. So I'll take this chance to explain about our high-resolution TV system. Okay, so in 1953, we introduced standard definition TV system in Japan, and then we updated to a high-definition thing in 2000. And then next year, we are running a test project for the next generation TV, and we call that an 8K system. And okay, so we recently made more than a few filming projects with the 8K system, including the last Olympic Games. So that means we can re-experience those exciting moments anytime, anywhere, if you buy the new TV. Yeah, so so what is the 8K? If I break down the features into like three, it's more pixels, faster pixels, and better pixels. More pixels. We have more pixels. We have like 4,000 times 8,000 pixels, and that's why we call it an 8K. And since the pixels are so dense, you cannot recognize those dots with human power of vision, and that makes the picture so smooth. And we have a wider range of field of view that makes the viewing experience quite immersive. And then these two factors create sensation of reality even in close viewing, which is a potential for, I think, VR use. Okay, faster pixels, we have more frames in second, you know how it works. And better pixels, we have wider range of color so that we could produce almost every color that exists on Earth, and we could actually is visible in the world. And better pixels. There's a technology that expands the range of brightness too. So I introduced three features, visual aspects that makes TV more immersive. But TV is not only about pictures, right? Audio is another important factor. And I think you've heard about the 5.1 surrounding system. But now we have 22.2, which means that you have to buy 24 speakers to match the full spec of this whole system. But you know, I know that's ridiculous, but what I mean is that the system could be operable to those highest requirements. And I'm not asking you to buy 24. Okay. So, well, I actually once heard a classical concert with this whole system with the 3D glasses, and I tell you, it was very stunning. And I'm very sorry that I couldn't bring the whole system here, but maybe next time I'll ask Stanford for the money to bring all this stuff. Okay, so we're thinking of applying these 8K technology into various fields. So we're developing those equipments like camera, and then production devices, and displays in various screen sizes. And we are thinking of applying these high-resolution equipments to medical use. And as you can see, these guys here are in the middle of a surgery. And they are attaching an 8K camera onto the endoscope. And of course, the doctors have better images of the surgical site. And it was last year that we did the Soccer World Cup live viewing project. The idea was to virtually bring the stadium with the sensation to the other side of the globe, and with the 8K system. And well, I'm sorry, this is the only picture that I could show you. There's a stupid copyright issue with the FIFA, and I hope you could feel the sensation from this single picture. But well, thank you. Thank you for listening. I'll be around.
One question I have, knowing your background in journalism, is as new media emerges, as we've learned earlier today, it's going to change how the message is delivered. And as media gets more high resolution, with virtual environments, we're able to change what people see a lot easier, and not just the visuals, but the behavior, the avatars, etc. We used to say, a picture never lies. We don't say that anymore. With virtual environments, how do you think that will change the storytelling?
Yeah, it's true that there could be more potential of false imaging and misguiding with those immersive images. Well, some people say that technology and robots are replacing the conventional journalist's place, but well, I think, yeah, here's the human role today. So I think the human journalist role are changing, and we have to make sure that the image is true or not. Nobody has made kind of a criteria for that, but we have to check if that's logically possible, or if whether like it's matching the context of the rest. And we have to be careful, and we have to recognize that that's a very new role in the digital age.
Mm-hmm. Well, thank you, and thank you for sharing the coming wave of new technology. Next is Dr. Louis Liu.
Okay, ladies and gentlemen, I feel very privileged to participate in this conference. And my name is Louis Liu from Electronic and Optoelectronic Research Laboratory, ITRI, from Taiwan. Okay, and we know in the last year, 2014, Microsoft issued a project about Rune Alive, and which is a proof of concept prototype to transfer any Rune into an immersive and augmented experience. And in the meantime, ITRI also initiated a project. It's mean Interplay. Okay, and this project also want to create an interactive environment between virtual reality and reality. This includes three scenarios. The first one scenario is an application for medical organs education. Is to project organs in your body. So anyone can to shift or to move the organs just from your body to simulate the education. The second one is an interactive game. It's in this game, there are a virtual mouse run away, and you can use a virtual knife to cut the mouse. Okay. The third one, in the space, there are many eyes to simulate many eyes to watch you. This is because we are engineers, we have to remove the eyes and to remove somebody watching you. Okay. So this is from our project Interplay, and in this month, Interplay is set up at a corner, a public corner of convenience store, 7-Eleven in Taiwan, and to let customer immersive themselves in a bookstore to be a reader. Okay, so this is a project, and so from this project we think this is an interactive ecosystem, including content and hardware device and the user interface. And we think content is a key to indicate the application the user. So several methodologies of content creation were developed by ITRI in the past year. This is the first one. This is one approach to real-time conversion the content directly from 2D streaming to 3D streaming. Okay, and this 3D image can be displayed on TV or glasses. And this is the second approach, use 3D scanner to generate a virtual object, also real time, and with a mono or full color object. Okay. And in addition to the content creation, we think the gesture control is an important user interface to let users issue their comments. So gesture control is an intuition-friendly interface for user. So another approach is combine the projection and the gesture control. So this not only keep the advantage of intuition, but also widen applications. This can be projected on any surface, application, and the scenario, and it can be applied this condition. So this is our presentation. Thank you.